to learn programming in Java, interfaces. I'm not going to say I have a favorite chapter, but this is my favorite chapter. Interfaces is a reference type like a class. Okay, it's used to define a contract that classes implement. An interface specifies a set of methods that a class must implement, but it does not provide implementation for these methods. Yes, it can, but let's get to that later. Instead, the implementing class is responsible for providing the actual code. So an interface defines the contract only. They're widely used in Java. They're fundamental to OO programming and to Java. They're a way, not so much to provide multiple inheritance, but as a way to provide multiple interfaces, which is not hierarchy or classification. So this is the way to go in terms of deciding between implementing an interface or setting up a hierarchy like inheritance. Interfaces is by far the preferred method. Let's look at the topics that we will go through. Method declaration only. In terms of interfaces, they contain method declarations only. Just the signatures, no body. I'll show you an example where that's not true, but in general, there's not a body, there's not implementation. These are both conceptually abstract and public, all right? Always abstract and public. You can declare some constants in there, kind of a code smell. They're implicitly both public, static, and final, all right? You can have many of them. A class can implement multiple interfaces, all right? I don't really think it's an limitation of inheritance. They're two different things, but you can have as many interfaces as you need. Okay, there are default and static methods. We'll see those. The interfaces can have a default method with the default implementation. I know I just said you couldn't do that, but there is a way to do that. It's kind of an exception to the overall design, but it does work, okay? You can have functional interfaces. These are interfaces exactly one abstract method were introduced for lambdas that includes runnable, callable, and comparator. We're going to see that much later in the functional programming, but I thought I'd mention that now. Okay, I wanted my example to be an interface example that just clearly could be used in different contexts. So I have something that is speakable. All right, I have a little Boolean. Notice that I don't need public. All right, so you know I have my little Boolean over here in my interface, speakable. I set it to true. And here's my contract with no body. See, no little parentheses. Okay, there's no need to put public or abstract. So my speakable interface has one method called speak. It does have a constant up here if you really want it. But here's what I want you to see. Okay, that I can be speakable. I could implement speakable both as a dog and a person. Now, are they the same thing? Is a dog a person? Does a person have a dog? I don't know. Who cares? But both these things are speakable because they will both have a speak method to override. Dog says woof, and of course I say hello world. The point here is that speakable defines an interface, a contract to speak, or just speak here. How that is done, not important. But once I implement speakable, then I am now a speakable object. I can be treated as something that can have this method called speak. I'm guaranteed that by the language at compile time. All right, this is a critical part of the language, and creating interfaces, implementing interfaces is core to the language and what you will be doing all the time as a programmer. All right, so what are the benefits? It decouples your interface. It provides a way to define the methods, but unrelated classes like dog and the person, they can implement what allows it to be flexible and loose. So something that has speak can be a dog or a person. All right, but what's important is the contract. You can have many of them. You can have multiple inheritance, actually, but you can have multiple interfaces. All right, it's polymorphic. Okay, interfaces allow for polymorphic behavior, meaning you can write code that works on an object of classes implementing the same interface, even if they're not related by inheritance, which is quite powerful. But couldn't I do that with an abstract class? Yeah, you could. A class can be abstract. Okay, you can have an abstract class that's designed to be inherited. Maybe you just have an abstract class and it just has methods, no bodies. I mean, it's useful for creating a common template. You can have it in a hierarchy. in C and C++, we used to have all these things, but I want to show you how they're different. All right, there's some key differences, okay? Abstract class cannot be instantiated, okay? That's why they're abstract. There are abstract methods that can contain there are abstract classes that can contain abstract methods without bodies, but there's also concrete methods. Unlike interfaces, abstract classes can also contain concrete methods. I can have a host of them. I mean, you can have just one abstract method and, I don't know, 20 concrete methods. You have constructors. Abstract classes can have constructors, which when they're used with a subclass are just like a regular parent class. All right. So these are two different things. Abstract classes basically only used for in the area of inheritance. They require kind of a hierarchy. Do we need them a lot? Maybe not. Why do I say maybe not? I mean, yeah, you can have fields and properties, which is not. You could kind of do it with the newer versions of Java, and you use an abstract class when there's a base class that you don't want ever to be instantiated on its own. You know, like the animal or shape, but it does provide a common foundation for multiple subclasses. So if you have that hierarchy, abstract classes are a good way to go. But the question is, why do you have a hierarchy? Why not just use interfaces? All right, for those of you who like little charts, pause. You can read through this here. Abstract classes versus interfaces. Go ahead, pause, read through that. Okay, you read through that. Let's look at some examples. Here's my speakable again that has a speak method. All right, no body. I have an abstract class mammal. Here's another example. Number of limbs, I can set it to 4. Mammals give milk. Oh, look, here's an abstract method. Okay, for an abstract class. So, I mean, by the way, I don't have to have, I can always have to be abstract keyword to be an abstract class. And I can have n number abstract methods, n being 0, too. So let's put this together. Here's my dog that is a mammal, and that implements a speakable interface. What does that mean? That means I have to override. Remember from the last chapter we talked about the annotation. So I have to speak to be speakable, and I have to give milk to be a mammal. So I can have both, all right? And I have to give implementation to both. But my abstract class, it could have other concrete methods. It has a constructor, all right? They're not the same, but the mammal is almost always used over here as an abstract class for hierarchy. The speakable interface doesn't have to have a hierarchy. It's not a hierarchy. It's just a contract that says something you can speak. Ooh, what are default methods in an interface? Okay, default methods are Java interfaces with a body. I know I just finished telling you that you don't have to have bodies, but they're introduced in Java 8. They're a way to kind of get around some criticisms about interfaces being, not as useful as they could be. It was a significant change. All right, you don't have to do it this way, but default methods enable developers to add new methods to interfaces without breaking existing implementations. So if you have an interface, and like the speak interface, and you add a default method, that does not break everyone, who was using that. You're just giving yourself more. What does that mean? Here's what I mean. A default method has an implementation. Okay, you don't have to do this, but you with the default keyword you can have an implementation, an actual body. Default methods are backwards compatible. Okay, they can access the implementing classes. They're still different from abstract classes. Okay, they don't have constructors, for example, and they don't participate in a hierarchy. All right, so this is kind of a mashup of something. You don't have to do this, but it is available. All right, give me an example. Here is an example. My speakable method is good and true speakable method, but now maybe I have a version 2.0 is speakable. Okay, it now has a default keyword, a default method. Look at the little curly braces, and now I have a default implementation. So mute, can mute. All right. I can also have a static method in here, How about that? That's available for everybody. So I can both have a method that's default, and I can also have static, and I can also have my little constants like I had before. All right. So this is an add-on to the language. You don't have to use it, but it could be very powerful, and it's backwards compatible. Hold up. What was that static method that you just showed me? So in Java interfaces, methods with a body that belong to the interface itself rather than any instance of the class, you can have a static method, which we just showed you before. It was we saw that in Java 8. It's new there. It's the same concept as static methods that you've seen before, but now on interfaces. So real quick, these static methods, they're an interface kind of utility thing. They have direct access. They cannot be inherited though. They can't be overridden like the other methods. And they're accessed using the good old dot notation that we've seen before. So it's something else to add to your tool belt. So if you forgot what that looks like, it's this guy. So I can have a static method in an interface, and it belongs to every instance. All right, it doesn't belong to the object. So it's a utility, something. Don't always have to have it, but now available. All right, yeah. If you want to compare and contrast, hit pause and look through this. Look at the difference between static methods and default methods in terms of access and overriding and purpose. Okay, you can inherit interfaces. You can extend methods to an interface. So you can implement an interface, and you can inherit an interface. Same copy and paste that whole discussion about inheritance, but you can have interfaces inherit from one another. That is possible. All right, so what are some of the features to inheriting interfaces? One interface extends another. You still use the extends keywords. You can still use the multiple kind of inheritance idea. There's no implementation requirement. So when a class implements an interface that extends another interface, it must implement all the abstract methods of the interface, okay? Unless they're default methods. So basically, the child interface class can add new methods. All right, you're not taking away any, obviously, but this is a way to add more. So my speakable interface can be extended and have more methods to it if you really need it. So what's an example of that? Here's my whisper interface extends speakable, and I'm adding methods so I can both speak and whisper. It's backwards compatible, and that's kind of the important thing. So do I have a favorite child? Yeah, it's interfaces. Okay, that's what we prefer. It's really the way to go. Yeah, if you like hierarchies, and in the old books you had mammal, you had shape, but really that's kind of gone the way of I don't know, cache and checks. Really, interfaces are the way to go. They've been extended. They're more flexible. They're more reusable. I like them, and that's something that you should be using and will be using as a Java developer. So thanks. That was interfaces, and let's get to the next chapter.